For decades, we thought we had our solar system figured out. Mercury, Venus, Earth, all the way to Neptune. Scientists have even discovered thousands of planets orbiting distant stars, some as big as Jupiter, others possibly like Earth. Yet, for all our knowledge of planets light years away, there might still be a giant, unseen planet hiding in the outer reaches of our own solar system. If true, this wouldn't be the first time we suspected a hidden planet long before directly observing it. The story begins in 1781, when William Herschel, originally a musician, used a telescope he built himself to discover Uranus. It didn't take this planet long to raise questions. Astronomers noted discrepancies between Uranus's actual positions and the predictions made by Newton's laws. These differences were too significant to write off as simple observation errors. By the early 19th century, mathematicians like John Couch Adams and Urbain Le Verrier proposed that another unseen planet, one with enough mass to tug on Uranus, had to exist even farther out. Le Verrier's calculations were so accurate that Johann Galle at the Berlin Observatory spotted Neptune in 1846 during just one night of targeted searching. This story became very famous. Purely theoretical calculations guided us to a new planet before anyone had actually seen it. This discovery immediately started new speculation. Could another planet be out there? Although Neptune accounted for many of Uranus's orbital oddities, some astronomers continued to notice small discrepancies that seemed unexplained by Neptune alone. Percival Lowell and his contemporaries believed these residual pulls on Uranus and Neptune might come from yet another massive body lurking in the dark, an unknown Planet X. Lowell's calculations suggested this hypothetical planet would be large enough to affect the orbits of the outer giants, but far enough away to escape direct detection with early 20th century telescopes. In the late 19th and early 20th centuries, Percival Lowell set out to find this so-called Planet X. From his Flagstaff Observatory, he systematically photographed the night sky, hunting for any point of light that shifted from one week to the next. Though Lowell passed away without catching his target, his work paved the way for Clyde Tombaugh to discover Pluto in 1930. At first, people thought Pluto was the long-sought Planet X, but it turned out to be far too small, only a tiny fraction of Earth's mass. The initial peculiarities in Uranus's orbit that had sparked the Planet X search were eventually resolved when astronomers got a better handle on Neptune's mass. By the mid-20th century, most scientists decided there was no need to assume any additional giant planet. But the idea never completely vanished. After all, we'd discovered Neptune and Pluto by noticing oddities in planetary orbits, so if more oddities turned up, we might suspect another hidden world. In the 1970s and 1980s, a few researchers revived the Planet X hypothesis to account for unexpected patterns in comet trajectories or strange movements in the outer solar system. Although most of these theories fell apart upon closer examination, some scientists still believe that there is more to discover in the solar system. Over time, the definition of a planet evolved as astronomers learned that Pluto was just one of many small, icy bodies in a distant zone beyond Neptune. This region, eventually named the Kuiper Belt, changed how we classify objects in the solar system. Discoveries of other bodies similar to Pluto led to its reclassification as a dwarf planet. Even though Planet X was originally just a placeholder term, the X stood for unknown, and for Lowell, it also implied a possible 10th planet. The name stuck in popular culture for decades. However, once Pluto was demoted, we were officially left with only 8 planets. So, any new gas giant-sized world discovered beyond Neptune wouldn't actually be the 10th. It would be the 9th major planet. That's why, in recent years, many astronomers prefer calling the hypothetical world Planet 9. So while old-style Planet X theories lost credibility, a new avenue of research opened in the late 20th century. Astronomers uncovered more and more trans-Neptunian objects, or TNOs, each offering clues about the outer reaches of our solar system. And once again, a few suggestive orbital patterns led some scientists to think something else, something large, might still be hidden out there. In 1992, astronomers spotted a small object orbiting beyond Pluto, officially called 1992 QB1. It was the first confirmed Kuiper Belt object, or KBO, aside from Pluto itself, and it was the first clue that more were out there. Over the following years, improved telescopes with digital detectors revealed a multitude of icy worlds beyond Neptune. Among the discoveries, objects like Sedna attracted particular attention. Found in 2003, Sedna has a highly elongated orbit that doesn't bring it closer than about 76 astronomical units from the Sun and can carry it well beyond 900 AU at its farthest point. This is an unusual path. Could Neptune alone toss an object that far out, or did Sedna's orbit form through something else, like a close encounter with another star or the gravitational influence of a hidden planet? Objects like Sedna are sometimes called detached or extended disk objects because their orbits seem to lie outside the zone where known planets can easily affect them. As astronomers discovered more TNOs with these detached orbits, the idea grew that an undiscovered massive planet might be shepherding them. By the early 21st century, powerful telescopes and surveys, such as those using the Subaru telescope, Pan-STARRS, and other wide-field projects, scanned large chunks of sky systematically. Computer algorithms helped identify any faint points of light that moved slightly over days or weeks. Thanks to these efforts, we learned the solar system extends far beyond Neptune in an extensive but sparsely populated ring. During this surge in TNO discoveries, astronomers noticed that some of these remote objects showed a strange clustering in their orbital traits. It wasn't just a couple of random oddities, but a small group displaying similar angles or directions. Statistical analysis hinted that these patterns couldn't be explained by pure coincidence. Supporters of the new planet hypothesis suggested a distant large body might be sculpting these orbits. Critics countered that observational biases or accumulated small gravitational effects could explain the patterns just as well. Even so, the idea grew more compelling. Scientists ran advanced simulations to see if a hypothetical giant planet, perhaps orbiting 200 to 1,000 astronomical units from the Sun, might shape TNO orbits in the ways we observe. In 2016, the Planet 9 theory gained significant traction, thanks primarily to the work of Konstantin Batygin and Mike Brown at the California Institute of Technology. They focused on 6 distant Kuiper Belt objects, whose orbits seemed to cluster in ways that defied the odds of random distributions. Specifically, these TNOs shared commonalities in their perihelion arguments and orbital inclinations, forming a pattern that chance alone struggled to reproduce. Batygin and Brown ran extensive computer models, trying everything from random TNO placements to intricate multi-body interactions among the known planets. The only scenario that consistently matched the observed data involved a hypothetical planet roughly 5 to 10 times as massive as Earth, orbiting on a highly elongated path hundreds of astronomical units away. In some setups, this planet would take more than 10,000 years to complete a single orbit around the Sun. Naturally, everyone asked, how could such a large planet exist so close by yet remain undiscovered? Wouldn't it appear in our telescope data by now? The explanation typically revolves around distance and brightness. If Planet 9 happens to be near aphelion, perhaps 500, 600, or even more astronomical units away, it would be reflecting a minuscule amount of sunlight, easily lost among distant stars. Brown and Batygin's models suggest Planet 9 might be on an orbit tilted relative to the ecliptic by 15 to 30 degrees. This is another reason it could be overlooked by traditional planet hunting surveys that focus on the ecliptic plane. As the hypothesis gained momentum, astronomers around the world tested it with new observations. Each fresh TNO discovery was checked. Did it fall into the predicted orbital pattern, or did it veer away? Researchers also explored other potential signals of Planet 9, like whether it might tilt the orbital planes of smaller bodies or create odd resonances in their orbits. It was a return to the planet-hunting excitement of past centuries, only this time powered by modern instruments and computer-aided surveys. To understand how astronomers are pursuing this hidden planet, we need to understand what they think Planet 9 might be like, and how they hope to pinpoint such a faint target across the vast sky. Advocates of the Planet 9 concept imagine a world somewhat like a scaled-down version of Uranus or Neptune, a so-called mini-Neptune or super-Earth. This mass range of 5 to 10 times that of Earth is common among exoplanets in other star systems, yet no such planet currently exists in our own solar system. If the planet is currently near its farthest point from the Sun, its apparent motion across the sky would be agonizingly slow, meaning astronomers would need months or years of repeated imaging to see any noticeable shift. Temperature and brightness are important factors. Even with a decent reflective surface, a planet so far away would appear very dim from Earth. And if it's smaller or has a lower albedo than expected, it becomes even tougher to detect. Crowded star fields, especially near the Milky Way's plane, can further conceal it. On the other hand, a planet with 5 to 10 Earth masses might still release a bit of internal heat, meaning it could have a faint infrared glow that telescopes could detect. The Wide Field Infrared Survey Explorer, or WISE, mapped the entire sky in infrared, so astronomers have scoured its data looking for clues. Nothing definitive has emerged. It could be that Planet 9's temperature or emission is too low, or that it was in a part of the sky where WISE's sensitivity wasn't enough. Another big question is how such a planet ended up on such a far-flung, eccentric path. One leading theory proposes that, early in the solar system's history, a Neptune-like world formed alongside the other giants, but was eventually flung outward by close gravitational encounters with Jupiter or Saturn. Instead of being completely ejected into interstellar space, it settled into a stable, wide orbit for billions of years. Another scenario is that the Sun captured a free-floating rogue planet, locking it into an orbit when it happened to pass by. Modeling suggests that, over millions of years, a planet of this size and distance could gradually influence the orbital planes of the known planets. It might also explain why some Kuiper Belt objects are tilted at extreme angles. Ultimately, the best proof would be seeing it directly, detecting either a faint flash of reflected light or a distinct infrared signature, but that's no easy task, given the enormous area of sky to cover and the planet's expected dimness. Astronomers often begin by defining a search region where Planet 9 is most likely to be found, based on current models. Then they use wide-field cameras on large telescopes to take images of wide swaths of sky. Over weeks or months, they compare these images to spot any object that moves even slightly. Once they have enough data, they try to figure out its orbit to determine whether it aligns with the predicted path of Planet 9 or if it is just another smaller TNO. As I mentioned earlier, Subaru in Hawaii is a popular choice for this work because of its powerful wide-field camera. Pan-STARRS, also in Hawaii, systematically scans the sky and has found countless near-Earth objects and TNOs. The Dark Energy Survey in Chile, although focused on understanding the universe at large, also detects solar system objects. The upcoming Vera Rubin Observatory in Chile will conduct an even more comprehensive survey of the sky. This is expected to vastly increase our detection of distant objects and might finally confirm or refute Planet 9. All these projects produce huge sets of images that can be combed through for slow-moving targets. Astronomers also go back to old photographic plates and digital archives. They reprocess old data using more advanced algorithms. Sometimes an object initially classified as a star might actually be a slowly moving dwarf planet, or even Planet 9. If that same dot appears in new images exactly where a Planet 9 orbit would predict, it provides valuable data on the object's path going back decades. Even a single archival detection can drastically narrow down the planet's possible locations. Despite all these efforts, Planet 9 remains undiscovered. Some astronomers believe that with ongoing improvements in instruments and wider sky coverage, we'll eventually find it, or we might just stumble upon it by sheer coincidence during another survey. Still, not everyone is convinced a hidden planet exists. Many argue that the evidence isn't strong enough yet and could be explained in simpler ways. A common objection involves observational bias. Telescopes spend more time looking in areas where TNOs at perihelion are brighter and easier to detect, which can create misleading patterns. Supporters of Planet 9 acknowledge these biases, but claim their calculations still show a real signal when factoring them in. Another viewpoint is that perhaps a large swarm of smaller TNOs is collectively nudging these orbits, producing the same clustering a single massive planet would. If this remote population has enough combined mass, their collective gravity might shape the alignments we see. Proving or disproving that hypothesis requires deeper TNO surveys and more precise estimates of their total mass. A related idea looks back to the solar system's infancy, when the Sun may have been part of a dense star cluster. A near pass by another star could have scattered objects onto these strange trajectories, including Sedna's. Such a stellar flyby is tough to confirm, but it's not impossible in a crowded birth cluster, especially if it happened when the solar system was young. Some astronomers propose more exotic ideas, like a mini black hole instead of a planet, though that's highly speculative. In the end, the debate over Planet 9 continues. Whether it's eventually found or explained away, the search has already expanded our understanding of the solar system's farthest reaches. If you enjoyed this video, don't forget to like, subscribe, and press the notification bell for more stories about the universe. Thanks for watching, and see you next time.